Hi. Thank you. So you guys know where I'm standing? I'm standing right between you and your lunch. So last meetup, I was the first speaker. Anand gave me 45 minutes time, and I took about 1.5 hours time. So now he has, very cleverly put me, in this session so that I won't take much time. So my goal is to take about 30 minutes. So let's see that. Right. So you can be a bad architect or a good architect, right? But to be an architect, you should first be a developer. Do you all agree?
Yes.
Great. Right. So I'm going to. It's that. Okay. So there is a small code I'm going to display. I got 10 seconds to find what's wrong with the code. You guys ready?
Yes.
So it's in Java, but doesn't matter whether you're a Java, C++, or C#. You can easily find it. There you go.
Places are missing after if you can have a place to write.
Okay. Anyone else? Right.
The method name, it is called as
It's
is
also
negative.
Okay. Anything else?
What if number is wrong?
Yeah,
Okay.
Accepting a number and then you're converting into string and doing something.
Okay.
Now what if the number is?
All right. That's the answer. So both of them does the same thing. It's okay, fine. But when you are looking into very small details such as what's the name of the method, or where you're converting the long to int, or what if an int is null, all these things. But eventually we tend to lose the big picture, right? So I'm here to just give you a small overview of what API design about. So I told you I'm going to take about 30 minutes. So it is not like before my session, hey, I'm an architect, I don't know how to do API or design an API. After 30 minutes, hey, I'm an architect, now I know how to design API. It's not the goal. So I'm going to just give you a little bit of overview of few things so that you can go back and then you can do your research and then you can get better at designing the APIs, right? So everybody loves code, so let us start with a nice code, and then also we will end up with another nice code. So this the session. So API design for architects. My name is Prakash. I am the co-founder of Cypal Solutions. We are into consulting and providing trainings in several topics from C#, .NET, MVC, Java, Eclipse plugin, all this stuff. So I started my career as a C++, a little bit with C++ core bar, moved to Java, worked in all the layers of JEE, and then I moved to Eclipse plugin development. So I served as a core member of the Eclipse platform UI team. I'm an Eclipse committer. And then I moved to .NET, and then my focus right now is full of .NET, EF, MVC, and a lot onto Azure. So I'm just helping few clients right now. Actually, 3 clients to move from the on-premises to Azure. All right, let's start. This is the agenda. Just 3 simple agenda. What's an API, and a little bit about what are the design considerations that you have to make, and then a few implementation tips. That's all. Right. Now, what is an API? Anyone? API.
Application programming.
Anything else?
Is it connect to the ecosystem?
No, API. What does it stand for?
It's abstraction, it's a contract between your client and us.
Yeah, that's the definition. API. These 3 characters, right? So, are you sure? How many of you have actively maintained an API for at least 2 years, whether you created the API or someone else created, whether you exposed only for your internal customers or given for external world, at least for 2 years? Then you guys will agree with me. This is the real definition of API, right? Seriously, because once you create an API, right, there is no way to go about it. APIs, there are different types of APIs. Like it can be a private API, means that you could create for yourself and only you use it, or it could be kind of protected. That means that you expose it to internally across other teams. For example, Anand gave a good example about the email utility. It's kind of an API. You create it, and then you have a little bit of control to how to use it and who your customers are. So that's why I call it as protected. And then you have a public API, something like Facebook or Twitter or Google Plus or any other ones who expose their API where you don't even know who your customers are. Typically in Eclipse, we also do we create a lot of API, then give it to external world. People develop a lot of plugins to Eclipse like that. So there are different types of API, and it could be in a Java or C# or JSON, REST, binary, or whatever form it is. But what is the truth about the API is that the API stays forever. Once you create an API and publish it, it just stays. All your customers, whoever uses your API, I'm calling you as customers, will always depend on that, and any change that you make would potentially break them. So if it is private, it means that you are the only guy using it. It's pretty easy for you, but otherwise, even if your internal clients or external clients, making changes is too hard. So that's why most of the web-based API, you can see V1, V2, V3, V4 like that. So they create a new set of API. That's not the same API, V1 and V2, right? So it's an extremely or entirely different set of API. And V1, whatever they created, that particular version stays forever until they say this API is duplicated and we'll be supporting for the next 1 year or 1 month, and then we'll be closing off, right? Yeah, it outlives your job. I have maintained some API in the past. I came out of the company, and then I created an API. I came out of the company, but that APIs are still being supported by someone else. I think that's the case for all of you. You could probably go and support the API that is someone else created, or whatever you created, someone else will be supporting later. Sometimes this is not going to happen, but outlives you as well. We might go out, but still the API might still be there. I still know one of my friend who is writing COBOL programs. You never know who wrote that program. All right. So that's why you got only one chance to do it right. So many of us, when we are in our early days of programming, say 2 years or 3 years, the first thing we tend to do is just like code. The API is other way around. You first think about it, make a lot of decisions, and then make it perfect, and then you create the API and then publish it. Because once it's published, it just, you need to support it and it lives forever. So that's the main difference between writing some code and then exposing an API. That's extremely true when you are exposing it to either to internal your others in the company or outside the company. All right. So let us look into a few design considerations. Compact versus complete, right? So what is this? When you create an API, you have to make a choice. These are a set of choices that you typically make. Whether you have to have a compact set of API or you have a complete set of API that you have a certain functionality that you want to expose. For example, you wrote an API. For example, you created an image resizing application, right? But you want to expose it to the entire world. Say anyone who is creating a website would like to resize that image and then fit it inside their, let's say, mobile browser, or in a tab, or in a PC, or in a giant 4K screen, right? So, but as soon as you are given with an image, you should be able to convert into that particular smaller images, given the resolution of the browser. So you read the browser's user agent, you should be able to resize it. Probably if the image, you can crop it intelligently. For example, a human is standing there and then the rest of the sky is there. If you do some analysis, you could crop only the human when you are cropping it like that. It is not just resizing I'm talking about, you're cropping something like that. You create it. You might have internally created a lot of logics. You don't have to expose all of them to the clients. Right? Internally, when you are using in your product, you could probably use a lot of options. But when you're exposing to the external client, would you like to provide all the options and give it as a complete API? Yes or no? Again, it depends on your scenarios, your business cases, and things like that. I'm just throwing in the options that you might have to encounter. And the other one is whether you want to create a small set of compact set of APIs which is usable for at least, let us say, 80% or 70% of your customer base which you are having in your mind. So this is the first decision you make. So whether you need to create a compact or a very minimal usable set of APIs. We call it as a MVP, right? A minimal viable product when you create a product. So and then keep on adding a lot of features to that. Similarly, you could have a first to gain traction or to provide correctness or anything. You create a compact set of APIs and then slowly in the next version, right? You could actually go and extend with all the other options and things like that, and create a complete set of complete APA. So this is one of the things that you would have to encounter, right? The next one is performance versus robustness. In many cases, you have to decide. This is like when you have a lot of checks, right? You would have to encounter performance. For example, in Eclipse, we have something called I selection. Okay, this could be either a text selection or structured selection. This, in turn, it could be a table selection, which could be applicable only for the table viewers, and here it could be for the tree viewers. And this is obviously could be applicable only for the editors I have. When you have an IDE, you could have three different type of. When you look at the errors view or problems view, you are looking at a table, right? When you have a solution explorer in Visual Studio or the package explorer in your Eclipse, you are looking at a tree viewer, and then editors are typically text selections. So, but when you are having just a structured editor, and then you are setting a selection internally at the Eclipse, we don't even check whether what is the type of that. We just try to assign it directly, because we would like to have more performance. If it is fails, obviously the developer will automatically know it and then he will correct it. We don't do any runtime checks. So there are a lot of examples like this. So you have 10 parameters in your functions, and each parameter you could check for the validity of whether it is null or not. If it is null, then throw an exception like that. So you could choose a path where you could have a robust API which does all the performance, checks, validity checks and things like that. Or you could go for the quick and fast way, which is like gives you the performance, but it is not robust. Your API might just die at any given point of time. Again, this decision is up to you. So certain times we just do certain checks. I mean, it's not that completely robust or completely performance oriented. Based on your situation, you could think of at what time should I make this validation test, and what time I do not do this. I directly go and just do whatever I want without any tests. So that is another consideration that you would have to make.
So that consideration, how will you decide?
That's what I'm telling you. So this is based on your, extremely based on your situation. Based on the scenario, you have to decide. In these cases, our target audience, most of the API, the good thing about having an API is most of the time your target audience is going to be another developer, right? So can the developer infer from your stack trace pretty easily? Is it buried inside somewhere, or as soon as you give the selection, you just set it on something or try to typecast it that time? So if it is a lot of if and else, and then if it is buried somewhere, then probably only the runtime user is going to hit. If it is just as a first statement, it cannot be null, then obviously your developer first time it is unit tests or in the QA test will find out. In those cases, probably you could just choose for going for the performance option. But if this buried somewhere in the middle, probably you just do a check and then throw a valid error message or something like that. Right? Okay. Abstract versus specific. You could be very abstract over certain APIs. For example, the structured viewers set selection is always structured selection. It doesn't care about table or tree like that. Or you could be more specific on that. Most of the web-based API, if you create, that would be, if you look at it, that would be more specific, right? So as I said, that it solves a very specific problem. Most of the web-based API, whether it's Twitter or Facebook, they just don't have any abstractness or derived classes or abstract classes, big class hierarchy or anything. If you look at any of those web APIs, they will have a Facebook post, a user, a page, comment, like. There is an action called comment, and an action called comment, adding comments like that, create a time. So all these things, you won't have too many layers of or hierarchy of classes in that. They are all just most of them are concrete classes, and they won't be very specific to what it does. But if you look at a language-based, any C# API or a pure Java-based API, you could see a lot of interfaces, a lot of abstract classes, and then you get your concrete classes. So you have to design carefully when you are doing for an abstract, because it would break pretty much easily. So when we design interfaces, we have we call it in Eclipse we call it as I*2 interfaces. For example, we will have I progress monitor. Okay, so we will always have our own default implementation, but the extenders can have their own implementation. We don't stop them. But if you want to add a new feature to this interface, can you do it in the next version? No, because for example, there is a method called A, and I added a method called B in the new version, and of course here I will add it, implementation. But when next version of Eclipse comes, that plugin, whoever is using there, it will break. Right? If they are extending my class, it would work fine. But here, because you are breaking the binary signature here, right? Because this particular class will not have B. So what we do is, like, we create another interface called iProgress Monitor 2, and then we will have this default class implemented. So your extender or whoever using your API, if they wish to provide the new interface, then they'll go for implementing this. So that is why you should always, when you are creating an interface-based programming, try to create a default class. This is very helpful for the implementer, so that they just can use this in any new versions. You could add like this. This is not I*2. Sometimes we have I*3 and I*4 interfaces also there, like that. So every year we create a new version of Eclipse. So we tend to create, whenever we extend our APIs, we always try to have like this. We don't actually break the binary compatibility of an API.
This is a question. Are you talking about Orion or your general web?
Orion is just web. I'm talking about Eclipse itself.
In Eclipse, where you are using APIs?
You have never written an Eclipse plugin, right?
Okay, plugin you are
Plugin, yes. So we write Eclipse, and then there are a lot of plugins. Say, for example, if you want to commit to SP and you use Subclipse,
Yes.
or you want to commit to
Yeah,
Git,
I
you
use
use
that,
eGit, all the stuff. So we are the core platform UI guys.
I was thinking what you were talking about Orion.
No. All right. So the next option is to have extensible versus customizable. So this is also kind of related to the first point, where to have compactness or completeness. If your API is complete with an entire set of functionalities, then probably your API is going to be more of customizable, right? Because you have provided the entire rich set of functionalities. All the extender or the user is going to just customize it and then use it. This is more or less in the case like you go with frameworks. But there are cases where the implementers are going to implement a new feature. In that case, they are just going to extend it, right? So again, coming back to my same Eclipse examples, like I am having a lot of views, a lot of editors, but whenever someone tries to create, let us say Groovy, they wanted to create a new editor, or they are coming with a new editor for some other new language, they are going to extend whatever it is available, and then they are going to provide their own configurations over that. So the editor will have editor source configurations, what are the keywords, what is the parser that is going to do, and let us say what are the colors that is going to have the keywords, what are the colors for variables, right? All this stuff, it's all kind of a configuration. But eventually what they are trying to do is they are extend via the available customizations for a product, right? So you also have to make a decision of how much of extension can third-party provider can give, and how much of customization can they do. Can they customize the whole thing? No, definitely not. I mean, there are several things that cannot be customizable. So it depends on your product. So you need to take up these decisions. So these are the 4 decisions that you will take. So whether you want to provide a complete interface, or you just want to provide a compact interface and then later extend with the different versions. You have to look at the performance and robustness, or sometimes you have to mix and match. But sometimes we will have a performance in some places, and then look for the robustness in the rest of the places by providing proper exceptions and stuff.
So
and you can be.
From the API point of view, how come? How do I get to know that this is performance and there's a robustness API is there?
A robustness means you throw in any junk at it, it will still perform. It won't just crash. It's as simple as this.
But as an end user, I really don't want to have a differentiation between that. Use this API for performance and use this API for robustness.
No. There should be the same API. So you need to take a decision on how it works. For example, again, I'll be giving a lot of examples for Eclipse because I've been maintaining and working here for about 6 years, right? So at Eclipse, what we do is we'll have an API. We just published it, and there is a developer who created a plugin for it. You try to install it, you try to click on somewhere, the entire Eclipse crashes. Would you like that? No. At least you should be able to say that this plugin has caused something and then throw it in an error log. That's what I'm saying. So in that case, there will be a performance definitely hit on that, because whenever we expose an API, there we'll do a lot of checks, whether the caller is calling with the right arguments. The example, is it trying to set a tree selection on a table? We'll do certain checks. Is coming selection, is it null or not? Is it having a valid set of values? Like that.
So is it significant enough to cause performance penalty?
That is the decision that you need to look at what are the tests that you are performing or the validations you are performing. If that validation includes going into a DB and finding out that user has a validation or blah 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 blah, and then takes about 100 seconds, then yes, it will have a problem, right? So that what is the validation that you are performing, that decides whether it is performance, whether it is hitting a performance or not.
Yeah.
Right? Okay, so and then we spoke about abstractness versus specificness, and then extensible and versus customizable.
Sir, one question here. What is the difference like abstract and extensible? How it differs?
Abstract and no, there are two different things. So abstract and specific means you can be okay, we'll explain about abstractness in the next few slides because that's the only thing I'm going to explain. Specificness.
Extensible, and the extensible also like abstract. Any class you can extend.
Need not be, right? So you could give concrete. You can give concrete classes and still be extendable.
Yeah. So.
And abstractness is you need to provide your own concrete classes. They don't need not be concrete classes. It's just purely interface-driven programming, right? You don't have final classes. You could still extend that case. Yes, again, it entirely depends on the scenario. We don't want the Eclipse to crash because of some bad plugin, right? So that's why, what are the tests, what are the validations that we perform, right? Always we just think of it, and if that validation is going to cause a lot of performance hits, then probably we would not do it, providing that it is not going to crash Eclipse, of course.
I suppose in API development, most of the time, almost always we put more weightage towards robustness.
Not necessarily. Again, it depends on your scenario. There are certain cases where we look for performance rather than robustness. I'll give you another example, right? So when you have a lot of menu items, right, whether in the context menu or in your file, that menu itself, the state of the menu could be based on a lot of things, right? For example, in a tree viewer or a table viewer, only if some of the items are selected, you could just enable the delete item. Correct me if I'm wrong, right? If there is no selections, then you don't have to do enable the delete method at all. That and all is very easy method, so we don't do any lot of checks. But there are certain methods which to decide whether to enable it or disable it, we need to do a lot of performance tests, right? What are checks that would take hit on performance? So in that case, what we will do is we will not do that. Rather, we will just say we are by default enabled. For example, your right click and commit. It should be enabled only if the entire tree, some file has been changed, right? In that case, you could just right click. While you're clicking doing the right click, you're not going to compute the thousands of files with your Git history or SVN history and then find whichever is that is changed or not. In that case, we don't even do the check. We'll just enable it. But the user, when he goes and clicks, hey, it's enabled, so I need to commit something. When you click it, then only it will just go and say that, hey, you have no files to commit. Like that. In that case, your API is not that robust because it's showing a wrong information. It's not about crashing, and just think about the user perspective, right? When you have delete enabled, you are able to delete it because there is something to delete. But whenever a commit is enabled, doesn't mean that there is always something to commit. Right? Same thing for update. It's even worse. You just need to contact the server and then find out if there are any changes from your code and then there's your source repository, like that. Okay?
I have one question. If I give you a choice to choose one out of each.
No, again I'm saying the goal is not to say this is good or that's good. Okay, so the goal is more like these are the choices that you need to make. When you go back, when you think of something, you always think of should it be compact or this? Should it be performance oriented or robust? Should it be abstract or be specific? This is a choice that you are going to make when you go back and trying to design something. I'm not going to say generically that this. No, it's entirely based on your situation. That's the design consideration that you need to create. Okay. All right. I'm just going to be explaining this abstractness with a small example. So I'm just going to skip it. Right. When I say be abstract, what it means. Right. So again, let's start with a nice code. The purpose of abstraction is not to be vague, but rather to create a new semantic level where one can be doing precise. When you start designing a lot of APIs, or at least work with a lot of APIs, you would really know what I mean. Okay. So here is an example. So in 1990s, I used to say I own a cycle. Right. 2000s, I used to say I own a bike. 2010s, I used to say I own a car. See, all these 3 times, I'm saying 3 different things. Why? Because I'm specific. In the other case, if I am abstract, it's all the same. Isn't it? So this is the power of having abstract over telling the specific things. Right? Maybe in 2040, I could own a helicopter or a jetpack. I would still say I would be having a vehicle. Right? So being abstract, what is the advantage? You get a flexibility. Right? You don't have to tell unless someone asks what is the type of vehicle you own, what are the capabilities, does it have gears, does it have 4 wheels, does it have a steering wheel, unless like that. Others are interested in getting the specifics. When you are abstract, you have the flexibility to change your implementation. Right? So that's why you need to be abstract in most of the cases. It's just very helpful in a lot of cases. Let us say, how many of you know something called Tirukkural? Okay, great. At least few of you. So that's just a small Tamil poet called Thiruvalluvar. He wrote about thousands of years ago. And a lot of that, even now, it is applicable. You know why? He never talks about actual mechanisms. He talks about governance. He never talks, well, of course, in some places he talks, but most of the cases he talks about governance. He doesn't talk about kings. That is why whether it's the time of a kings or time of a church or a time of elected government, the governance still is the same. Right? So he talks about morely about leaders rather than kings. That's the abstract level he is talking about. That's why you see a lot of current situation still fits about for the poem that's written 2000 years ago. Right? So that's the flexibility that gives you. And result in longevity. Yeah. So 2000 years or another 1000 years, maybe instead of government, people elected government, some form of government might come, but still the governance and the leaders and leadership skills that they want would still remain the same, whether they are a king or a PM or or a president or whatever it is. All right, coming up is a Java example. So what is the problem with this? I have a lot of children, so I just store an array list and then giving it back.
You're returning a complete class, array list. Instead of that, you
Correct.
return a list.
So if I need to change it to a linked list instead of array list, then I need to go and change and update all my clients, which would be actually impossible if I am just exposing it to third parties. I don't even know, especially I don't even know who the third parties are, right? So I could just make it as a base class called list, but still, because children, this is not a list, right? It's more of a set, unique set. You cannot have 2 objects in the same thing. Exactly. So you just try to be as abstract as possible. In that case, whatever your internal details, implementation details are, you could have the flexibility to change at any given point of time, as long as, of course, it's fitting the collection, right? So that's the power of abstractness. So when you are defining an API, try to be more abstract in this case. right? You can keep on changing your implementation, and it would still help you. Giving out these collections like this also is not good. Any idea? I've not written it here. Yeah, Gendex was one. It's about talking about the mutable things, right? So for example, what happens if that client who gets, whether it's a list or linked list or hash, it just goes and adds a children to you or modifies it? No, I'm not giving it here, but just as in most of the cases in this, like you are giving out something which you don't control or you want to control, but you are giving it to a third party. Try to give a new object of that, new copy of that. That way, if they modify the objects or modify the copies, you will still be, won't have an effect on that. All right. So the more abstract you are, so it is easier for you to change the implementation without breaking your clients. So that's the point. I mean, anyway, you can change it, even the previous, but all your clients also need to change. If you are more abstract, you can easily change, and yeah, no need to change the clients. All right. So we are coming to almost to the last thing, implementation tips. Whenever we create any API, right, the first thing we tell ourselves, you need to write or create a prototype client and then try to call. Right? How many of you are working with AngularJS? Very few. How many of you feeling that it's very easy? No. Because Google pays the developers to create an AngularJS, they don't even care, or they have never created applications out of AngularJS. Only when you sit in your developer seats or customer seats who consume the API, then you would feel the pain. Right? On the other hand, if how many of you using React? Correct. Is it easier? Right? So it is actually a lot better than Angular because those APIs are created by actual developers who are developing the web application, right? So when you are creating an API, you're given a chance to create a web API, any API, whether it's a web-based API or JSON-based, C#, whatever it is. The first thing you need to do is try to prototype a client. That's the first thing you know. Then only you will understand. You put yourself in the shoes of your implementer or extender or the end user. Then you will know what are the pains in using that API. Right? AngularJS is a very typical example. I would always say that because most of them are like paid by Google. They have not developed many of a web applications, but they are just trying to create an API for developing a web application. It's a disaster, right? And don't stop with that. There's a rule of threes in creating an API. Right? And if you are able to create one client, right, it might probably work for others because you are thinking in only one focus area, right? But if you are trying to create two clients, then probably it might support everybody with a little bit of difficulty. But if you are creating at least 3 clients, which means that not just the 3 same applications in different way, you should think about how to use your application or API in 3 different ways, right? So for example, Facebook is creating an API, right? Or Twitter, or let us say Google Plus. You try to create 3 different applications for that. One could be analyzing the user's feed and then finding out who his friends are, then thereby probably what are the type of posts he might like, so that you can just show it in the first. Another one, probably to recreate the Facebook client itself in your web application for some reason, just for a fun or something like that. Third one could be analyze something else so that you could post it or filter it based on it, like that. You should try to have at least 3 different use cases for your API and try to create your API. You will always have a better API resulting out of that. Right? Designing API is another thing. Trying to use from a different point of view is a different thing. So this is one thing, whenever you create an API, you should always try to do. You should always try to create at least 3 different API clients to consume that. Okay? The rule of use. Any idea what's this? First is usable. There are some APIs which is really, really hard to use. For example, in Java vector, right? If you want just a sublist or something like that, from 10 to 12, how would you do it? No, there is no API, you can think of it. But they the same thing, you come back to list, they have a sublist. Right? Because vector is come from 1.1 or 1.0, they have not thought about all those particular use cases, right? Because mostly they didn't try to use it extensively, so they don't have the completeness. So when you have, you can be compact, but you should have at least most of the functionalities that are used by everybody. In that case, Vector was missing that, which list fulfilled that. Like that, your API should be usable. If you look at Facebook API, it's little hard, and you cannot just get by getting a user and then let's say I go and read stream. I won't get the entire details. I'll say somebody has posted in my wall, but again, who posted it? Then I need to go and make another API. How many comments are that post? How many more to make another API? How many people favorited? I'm going to go and to make other API call like that. So I need to do a lot of API calls. But I think they carefully did that because it's painful to create Facebook-based applications. But on the other case, if you go for Twitter, they provide a very comprehensive API. Just get one thing; it has the entire tree by itself. It's very easy to use that. And scalable. In many cases, you need to think of, let us say you have a parameter, let's say same example, I'm just trying to set a selection. What if the tree has 1 million items? Let us say the tree is representing my my C colon, and I'm trying to set the selection of, let us say 100 items or say 1,000 items. Will it scale? So you need to look at whether the API will scale from 1 or 2 elements to several thousands or several millions, depending on your problem domain. You should always think of, because creating a simple API that works for a very small set of numbers is very trivial. But when you try to scale that number, whatever input you are getting, right? What happens if it, some X? That X depends on your problem domain. It is 1,000 or million or 100 millions, whatever it is. You try to think of that scalability stuff, then you will have a different view of your API itself. And extendable, obviously, right? So when you create an API, assume that there will be always someone who try to extend it. This is not applicable for your web-based, JSON-based APIs, but when a C# or Java. That's why most of the time you would have interface-based, and then you will have all this stuff. So think of that, somebody else will always try to extend it or customize it. So what are the points of customization, point of extensibility you allow? And of course, please document it. It's not there, but you should be doing it. Okay? And the last one, design for concurrency. What will happen if the same API call is called by 100 clients at the same time, or when there are 2 different API calls called at the same time? Let us say add and remove on the same class, right? So thinking of concurrency should be done at a very earlier level rather than going and doing everything, and then when you're exposing it to the client, you're doing it, right? Try to do it at a very earlier level itself. All right, that's almost the end. So what's an architect job? I think Anand gave you an excellent example, but I would like to end up this with a quote, right? An architect's job is not about to tell what to use, what the tool to use, what the framework to use, what the language to use. No, it's not that. And it's not where to use it. If you have a specific library, where to use it. No, that's even not an architect's job. Let's not even say how to use it, but rather you take it the other way around and say that it's mostly about to decide what are the stuff that you shouldn't be using for a given problem, right? So what are the stuff you should not be using, either tool or a language or anything, and what you shouldn't be, where you shouldn't be using it. Sometimes we use the right thing but at the wrong place, right? You shouldn't be using this. Can't use sessions in a DB call. Take the user ID from the session from the DB call. Simple example. Where you should not be using. That's all the stuff you should be thinking about and advising developers. And how you shouldn't be using it. Sometimes I see a lot of abused code. The same library, they try to abuse it at different times. Once I saw that, they had a logging, and they were just having an appender for a JMS, and they log enormous amount of log statements in their application. Basically, they are just bringing down the JMS server itself. So that case, you just be able to go and advise them, how not to use that logging. Of course, if you need a JMS, you just don't set the level to log debug. only when there is an error or something like that, put like that. So how to use it also more important. You just need to know how not to use it, right? So any idea of who said this? Exactly. I just thought it about last night. And think of it, I mean, yeah, there are 452 years of experience in this room. We should put some quote from someone here, right? All right, so now time for QA. Anyone? I think I'm on time. 1:15 exactly.
Any
Yeah.
drawback of providing too much abstraction?
Yeah, too much. There are also another say. Any problem in the computer can be solved by having another abstract layer, except for having too many layers. I don't know. When you have too many layers, there is always confusion. So you have to be very specific about it. When we learned in your school books, we always read about what 7 layers of networking or 9 layers of networking, whatever it is. But in practical, what do we have? We have physical layer. Above that, it's TCP or IP, and then your application. That's it. Probably HTTP or FTP. One more protocol we would have, and above that, it's just we don't talk anyway TCP or IP. We just have 4 layers. That's it. So you should have multiple layers. Yes, you cannot have just one layer monolithic thing, but having a meaningful layer. We always call it as like there can be 3 type of software. One's like banana. It's layered, right? It has a soft core fruit, eatable fruit inside, then the peelable thing which you can just throw off. It's exactly how the layering software should be. Each layer should have its own functionality, its own abstraction, its own user, right? So the second one is more like an onion. You have so much layers, and most of them are doing the same thing. I mean, nothing. The third one is like carrot. The entire thing is just one big monolith. Yeah, it's tasty, but sometimes it's not helpful. So how do you decide your layers? It's up again. I give it to your choice whether you want to have a banana or carrot or onion. It's all up to you.
So any security consideration during API development?
Yes. I mean, if you are especially exposing it to third-party developers, and then you need to look into all sort of security stuff like OAuth, token-based. But again, in these cases, what you should be doing is you don't tie that with your API itself. You abstract a layer above that, and probably not just security, it could be a quality of service as well, right? So one user cannot abuse your entire resources. He can call only 15 API calls per second or per minute, like that. So this is all another cross-cutting concern. You take it out of your API and provide as a layer, your answer. So that could be a different layer, QoS or security, all this stuff.
What type of layer you have used for APIs?
Well, we don't have any securities, but kind of banana. We got to work with the best of the minds in the industry. Eric Gamma, Gang of 4. He was one of the first guys in the Eclipse to start with.
Yeah, there is a question. This scalability issue, when there's an incident which happened, we design the entire applications, and when we try to deliver it, then the scalability was an issue because the application front end was slow because the data was taking time to do the operations, and then we stopped the project.
Okay.
So
No, even sometime back, I do a lot of consulting, right? So one of the things at the earlier level we try to do is the developer will not get into the scalability problem. You design the entire architecture such that, and define the breaking point, right? Any application which you design definitely will have a breaking point. At 1,000 users, this might break, or 10,000 users might break, or 1 million users might break. So you need to look at what point your entire application might break, and then you convince your stakeholders on that, and then design accordingly. So that's the job of an architect rather than giving it to the developers. So we always think about, first thing I will say, how many users, how many concurrent users, all this stuff, then only we go into designing that. Whether it's an application or API. It's the same. Any more questions? All right, I think it's time for lunch, but just small commercial break. So this is what we offer. So I'm doing a lot of consulting, both in Java, Azure, C#, all this, blah, blah, blah. In addition to that, we do a lot of training courses. customized to your needs, whether it be EF or Eclipse plugin development or even Bootstrap, all this stuff. So if you need anything, you know where to look at.
Do you have any recommendation for API testing tools?
API testing tools, no, I haven't tried. Sorry. All right, thank you.